Go ahead and try the bell work and insert your answers for number 1 and number 2. Okay, so I got root 3 comma 1 for number 1, and for number 2 I got 14 and 5 pi over 3, or you could have said negative pi over 3 since I didn't give you any restrictions. Okay, so we're going to simply define a polar equation as an equation written in r and theta. And so the two most simple polar equations that you can have are r equals a or theta equals a. So let's look at what r equals a looks like. So if I say r equals a, that means I'm not giving any restrictions on what the angle is. All I care about is that you've gone out a certain amount a. So you could go out a certain amount a here. You would have this point a 0. You could go out a certain amount a here. You would have this point a comma pi over 2. You could go out a certain amount a here. You would have this point a pi. And you could go a certain amount a here. You would have a 3 pi over 2. So, and you could also do all of the angles in between each of those. And hopefully you're noticing that you're getting a very poorly drawn circle. So if I have r equals a, then that gives me a circle. If we have theta equals a, then that means I don't care what r is, as in I don't care how far you go out from the pole. All I care about is that you're doing it on a specific angle. So that would look more like this, where this is your angle A, and you've plotted every single value for r. So again, you don't care what r is here, you don't care how far you go from the pole, all you care about is that you do it at a specific angle. So when we convert rectangular and polar coordinates, we need to keep in mind that polar equations are usually solved for r or r squared. So let's try this first example where we want to find a polar equation for the given rectangular equation. So remember that from yesterday we know that x is equal to r times the sine of theta. I'm sorry, x is equal to r times the cosine of theta. And y is equal to r times the sine of theta. So if I take this equation and I substitute in for x squared, r cosine of theta, and squared. For y, I substitute r sine of theta. I can simplify this to get r squared cosine squared of theta plus r squared sine squared of theta is equal to 16, which I can then factor out an r squared to get cosine squared of theta plus sine squared of theta, which should look super familiar to you. We should remember that's equal to 1, so that means r squared times 1 equals 16. Or r is equal to 4. So if r is equal to 4, this would be a circle with radius 4, according to what we learned in this box right over here, and according to what we know about the equation x squared plus y squared equals 16. We know that that would be a circle centered at the origin with a radius of 4. So let's try this next one. We want to find a polar equation for the given rectangular equation, and all we're given is that x equals 4. So we know that this is in rectangular coordinates, we know that it is a vertical line right here. So let's replace x with r times the cosine of theta. And again, we want to solve for r, so we're going to divide by cosine of theta. So we get r equals 4 times the secant of theta. So this would give us that same vertical line that we just graphed over there. So in this example, our goal is to find a polar equation for the given rectangular equation. So let's go ahead and graph what we know this rectangular equation would look like. We know the center would be at 3, 0. and we know that the radius is 9. So just like that. And now let's go ahead and convert that to polar form. So I'll do that right here. So I'm going to replace x with r times the cosine of theta minus 3 squared. And I'm going to replace y with r times the sine of theta, and that's still going to be equal to 9. So then when I square r cosine of theta minus 3, I get r squared cosine squared of theta minus 6r cosine of theta plus 9 plus r squared sine squared of theta is equal to 9. And now let's see, let's rewrite this. So r squared cosine squared of theta plus r squared sine squared of theta minus 6r cosine of theta plus 9 equals 9. Well, we know from our previous example that we can factor the r squared out right here. So that's going to give us cosine squared of theta plus sine squared of theta left, minus 6r cosine of theta. And let's go ahead and subtract that 9 to the other side so that we get 0. So now I'm left with r squared minus 6r cosine of theta equals 0. And if I factor out an r, I get r minus 6 cosine of theta. And so then, and this is one of the only times you can do this, you are allowed to divide that r on either side. And we get r equals 6 times the cosine of theta. So this is what the polar form of the equation is going to look like. And let's see if we can graph this by plotting some points. So r equals 6 times the cosine of theta. So we'll go ahead and make a table for theta, r, and also I'm going to make a column for approximate r, since some of these are going to be given in exact values. So if theta is 0, not theta, if theta is 0, then cosine at 0 is 1, so then 1 times 6 would be 6. So we know we have the ordered pair, or the polar form ordered pair, 0, 6. So that would be angle 0 and 6 away from the pole. If theta is pi over 6, the cosine at pi over 6 is root 3 over 2, so 6 times that would give us 3 root 3, which is about 5.2. So at the angle pi over 6, we're going to go out 1, 2, 3, 4, 5.2. And then at pi over 4, we know that cosine is root 2 over 2, so 6 times that would give us 3 times the square root of 2, which is about 4.2. So at pi over 4, we're going to go out about 1, 2, 3, 4.2. And then let's see, at pi over 3, we know that the cosine at pi over 3 is 1/2, so that would give us 3. 6 times 1/2 is 3. So at pi over 3, we're going to go out 1, 2, 3. And now let's do pi over 2. The cosine at pi over 2 is 0, so that would give us 0. So we have that ordered pair. So now go ahead and fill in the table for 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi, please. Okay, so that's what I got for the rest of the values. So at 2 pi over 3, it says to go negative 3, so I need to go the opposite direction from the pole, 1, 2, 3. And then at 3 pi over 4, I need to go negative 4.2. And at 5 pi over 6, I need to go negative 5.2. So we are getting this circle. So if I were to lay that rectangular circle, or the circle graphed on the rectangular plane, over the circle graphed on the polar plane, I would get the exact same image. So that's important to know, that whether you're graphing something in polar form or rectangular form, your image is still going to be the same. And also notice that our circle's diameter is 6, and that the center of the circle is located on the polar axis. So that has to do with this being cosine. So because it is cosine, it's going to be located on the polar axis, and then 6 is telling you the diameter. So let's go down here and try graphing this example. So in this example, our center is 0, 2, and our radius is 4. So our circle looks like that. So let's think about what could the polar form of this equation be. So let's think about the patterns from up above, and let's think what is the best option. So we would have r equals, so since up above the diameter was 6, and that was the coefficient in the equation, so here our diameter is 4. And then this isn't located on the polar axis, it's located on the pi over 2 axis, so then this would be sine of theta. But let's make sure that it works. Let's verify algebraically. So let's see, let's rewrite this equation, x squared, actually I'm going to zoom in a little bit more. So let's rewrite this equation, x squared plus y minus 2 squared is equal to 4. So I'm going to rewrite this as r cosine of theta squared plus r sine of theta minus 2 squared is equal to 4. So that would give us r squared cosine squared of theta plus r squared sine squared of theta minus 4r sine theta plus 4 equals 4. Go ahead and factor out that r squared. Subtract that 4 to the other side to get 0. So now we have r squared minus 4r sine of theta equals 0. We know that we could, let's think about this a little bit differently than we did last time. We could set those two things equal to each other, and then we could divide out an r, and we get r equals 4 times the sine of theta, which is what we conjectured.